So, should we talk about React? React hooks in production? I'm sorry, I wish I could talk about that, but by quick show of hands, how many of you are JavaScript developers? Okay, that's quite a few. And Node.js developers? Not front end. That's a good number. So, and how many of you already use ES modules? Already. And not transpiling it using Babel or TypeScript. Using ES modules in Node.js in production. Not a lot? It's not. They're not out of experimental yet. You should not use them. But we're here to talk about ES modules because I cannot talk about React. That's pretty much one of the only things I'm good enough to talk about. A little bit about myself. Yeah, that's me. A few days ago. Actually a year. But I'm Ujjwal. Hello. But if this. I am at RiserKukan on Twitter and GitHub. If you want to post a rant at me, feel free. I am one of the core collaborators in Node.js. That's why I'm here to speak to you all. I am also a member of the upgrades working group at Electron, which means I'm a co-maintainer. I contribute to V8 a little bit, especially these days moving forwards. And I contribute to different proposals and specifications at TC39. I've been affiliated with Google Summer of Code previously, and I'm a student. And the last point is more for myself. I need to assure myself every few minutes, you got this. And a quick disclaimer, I hate to do these, but I have to sometimes to set the right expectations for you all. The cake is a lie. We trapped you all here, now you can't leave the room. I lied about the presentation. This presentation is purely educational, which means that there are no takeaways. You can't go back to work and apply any of these principles because it's a purely educational presentation. There are no grand discoveries, no great revelations, no clever innovations. There's no point in this presentation where it's going to go from boring to, hey, we launched a new JavaScript framework. No, it's going to end at boring. And it's just talking about systems, trusty old systems that we've been using ever since the conception of JavaScript. We use a lot of systems, use type systems. If you're using Flow or TypeScript, use Webpack, Babel. But module systems have been around ever since we had absolutely nothing. Module systems have existed ever since we had JavaScript. Then why? Why am I even giving this presentation? Why do you even need this presentation if there's nothing you gain from it, right? So if you, oh, by the way, there's QR codes. If you want to follow these links, you can scan these. But if you see, we have a blog at Node.js collection. Parts of the implementation have been controversial and received pushback from the community. So if you're on Twitter, you notice about ESM being super heated as a subject, people being like, oh, these people are retarded, why they keep screwing this up? And for example, Lynn wrote a great article about ES modules, and this is actually super small, many JavaScript, so I quoted this. She says, many JavaScript developers know that ES6 modules have been controversial, but few actually understand how ES modules work. But then you'd ask me, but what's wrong with that? Why do we need to understand how a module system works internally? As long as we can use it, it's good enough, right? Why do we need to know how it works behind the scenes? Because of this. You don't want to do this. So you don't want to go to Twitter and talk about things like, so this gentleman says, it adds useless complexity to a world that desperately needs clarity and simplicity. I mean, we make mistakes. We're humans too, right? But a lot of these decisions were not done inside closed rooms. We don't like hurting you with stuff like, oh, MJS extension, just deal with it. No, it had to be done for reasons. You're here with me to discuss why these reasons exist. Why is module systems hard? What's so special about module systems? And why you should not go on Twitter and rant about stuff even though you do not understand why it is or how it works. Or, yeah, ESM package all day long. MJS feels gross to me. But let's start from the basics. What is a module? We've been using modules a lot. Modules are the fundamental building blocks of the code structure, no matter which language you use. If you do not use JavaScript at the back end, you're using some sort of modules. Python has modules, Ruby has modules, everything is modules. But how do we get here? How do we get to the point where we're arguing between two completely working systems technically, right? CJS has been working for Node.js developers for years now, and now we have ES modules all of a sudden. So let's talk about a history for a little while so that you have enough context. So it's 1996, Tupac's still around, rest in peace, and everything is great. It is a golden age of technology. DVDs were launched in Japan at that time. By the way, how many of you were alive in 1996? Quite a few of you. I was not, but it was a great time to be. Windows NT was launched and all that stuff, but the web was an exciting place. The web was an exciting place because Internet Explorer 3 was launched, and David, in this scenario, Netscape, had to figure something out to kill the Goliath, right? And they did something really amazing. So in March of 1996, JavaScript 1.0 was released in a famous 10-day period by Brendan Eich, in which he created a complete goddamn language in 10 days. And people started using JavaScript in HTML scripts, but these people were not JavaScript developers by a long shot, right? They were mostly PHP developers, or they were writing something else, and they were just rendering JavaScript. So these people were using JavaScript now, but they were only doing some really small things, and they were using it as a toy language mostly. So the era of the script tag began, and we used to use like 12 script tags on each file. And well, if your JavaScript code is too long, you try to break it up into multiple files, and you just included all of them as script tags. Now this has a couple of benefits. This gives you basic modularity, which means you can break your code into files, but there was a drawback. So there's no dependency resolution. At no point can you say use a function or a variable from some other file into the file that you're using. And it is namespace pollution. So because everything is a global, it's all in the global namespace. This went well for people until 2005 when 50 Cent was reigning. But in 2005, some interesting things started to happen around in the JavaScript scene. Notably, we created some really cool and bigger applications. So we had PrototypeJS. Who remembers PrototypeJS? It was a JavaScript framework created by Sam Stephenson for Ajax support. But we were entering the era of Ajax. JavaScript was now starting to be used for bigger and bigger applications. And then we stumbled on something. In August 2006, we stumbled onto something. We live in 2019 right now. And React is huge, right? We have React conferences and React developers and people with purely React on their resume. We had our own React back in the day. We had jQuery. And it was followed by underscore later and Lodash, which used the same approach. But these had a certain way of doing things, which was if you have so many global variables, use ifs. And ifs reduce all those global variables into a single variable. So the benefits of that was you have now basic modularity. If you remember jQuery had a symbol, the dollar symbol, and you can use all the jQuery functions from that. You had much less namespace pollution. There's only one variable now. But there was drawbacks to that. There was still no dependency resolution. If you ever remember using your jQuery, importing your jQuery JavaScript file below any of your other files, then the jQuery symbol was undefined. And there was namespace pollution still. We are perfectionists and we don't want even a single variable in the global namespace. And messy syntax. Did anybody really like writing ifs? I still hate them. Like we have to write them for tests and stuff. But they're so like inelegant. But we had Fire. We had discovered Fire. We had something of a base to build upon. We had something that looked like a module format. But it was not good enough. And in 2009, some crazy kid came up with the idea of running JavaScript on the server. This was Randall at JSConf.eu who realized that we could run JavaScript on the server and created Node.js. They had a way of denoting modules, which was called server.js, that changed its name to common.js later because it was supposed to be a common base for all JavaScript applications. Now there was benefits to this. Common.js was designed from the ground up to be a proper module system. It had proper modularity, which is just like you'd imagine Python or Ruby working like. It was independent of HTML. So you can require files inside other files, and you didn't need HTML to write JavaScript, which made sense for Node.js because there was no HTML, right? Now the drawbacks of that was the synchronous require, which makes sense in Node.js. You can synchronously require files because unless you have file system, you can't use file system. But synchronous requires do not make a lot of sense if you notice on the front end, where it might take a lot of time for you to load the modules and you don't want to block the event loop because of that. The fact remains, Node.js did not like CommonJS because of a lot of things in the proposal, and because of that, it did not implement it perfectly. There were front-end implementations that we all remember and love. There was Browserify, and there was Webpack. We still use Webpack, and Webpack allows you to require files and then bundle them. But CommonJS also hated front-end JavaScript because of the synchronous require problem that I told you about. It did not, like, it made no sense whatsoever to do that in the front end, and because of that, there was an idea. Let's make a proposal. Make a proposal for asynchronous require that makes it barely usable on the front end, and people made that proposal and called it module/transfer/C. This proposal would then go on to become asynchronous module definition. Now we remember AMD and AngularJS as being one of the champions of AMD. It had dependency, for the first time in front end, it had dependency injection. So you could require different modules inside of your Angular and components inside Angular. It's so cool. And Dojo started using AMD, which turned into James Burke pivoted from Dojo to work on require.js. Now this is something that we all remember. Require.js was huge in the front end community. But while everything seems to be working from the front end community, please keep in mind that there's still a schism. There's still we have unraveled the communities. The front end community is using AMD while the back end community is using CJS. They're using two completely different things, and that means that they're never on the same page as anyone, because these two makes more sense on their specific platform. All problems are solved, let's go home, but not quite. The problems before AMD and CJS were that we had no proper module system, there was no dependency resolution, and there was namespace pollution. And CJS is working quite fine for back-end developers, but for front-end developers, AMD, there's still problems. Verbosity, because AMD had a very verbose syntax, it was not as simple as just calling import, if you remember. You had to call defines and stuff. And, well, the clicker seems to be. Yeah, and there was strictness pertaining to order. So if you required objects in a particular order, you had to also use them in the same particular order inside your functions, which was very tedious for a lot of people. And then, of course, AMD was absolutely useless for most people because of just HTTP 1.1 things. You cannot, because of the limitations of HTTP 1.1, if you remember, you cannot really import 17 files and expect that to work perfectly. You need to concatenate them into a single bundle, which people like to do more. So because people realized that because HTTP1 was the thing that they used and they needed bundles, the developers realized that they would just use CJS on the browser, and this is, AMD developers were like pretty much actually they were really sad about nobody using their proposal and everybody regressing back to CJS. But there was a rise of module bundlers. So you could write CJS on your front end code, which made no sense because there's no CJS on the front end. But then these bundlers like Webpack would actually process your bundle and create a single big JavaScript file that you can actually import. And this is what we do with React still these days because most people are still not using HTTP2. Now, everybody uses CJS on both the server and the browser, right? So problem solved. Order has been restored to the galaxy. The problem is not quite. So module authors were dealing with a different problem now. Module authors had a problem that they could not determine who was using what. Because if you're using something other than CJS, if you're using something other than AMD, how do they make sure that their modules are usable in whatever format you're using? So we had an idea that was the universal module definition. Now, there's a lot of problems that come with anything that calls itself universal, USB-C, right? And this was the problem. We tried to solve the problem of 17 different module systems by creating a universal module system, but we just have 17 plus 1 module systems now because nobody liked UMD, and UMD was just another big issue that people would be scared to deal with. So we don't have sound, but so TC39 was essentially like, and TC39 was like, we're done with your shit. We need to do something about this. We need to add something. It's enough time that we added something to the language itself, something that makes sense. Because module systems make sense in the language. Python, you don't need a new module to need modules. And I'm not going to talk about Go because it's a shithole. But yeah, and we had ECMAScript modules inside the language. How cool, right? So ECMAScript module had static imports, and static imports were cool in ways we'll talk about really soon, but there was a problem. Because there were static imports, which is something that CJS does not like, and CJS completely depends on dynamic importing files, it crosswords with CJS, which meant that by extension, ESM had to crosswords with Node.js. Now this is the interesting part. The writers of the module, the creators of ES modules, the original people sitting at TC39 decided at some point that Node.js was not valuable enough for them, and they moved ahead with the proposal. This meant that while the whole JavaScript community moved forward, Node.js lagged behind because ES modules was never originally meant to work on Node.js, and that's very sad. And later we added dynamic support for dynamic imports, which solves this problem, but again, we're going to talk about that later. So static imports, yay, cool, right? Front-end developers love static imports because they give you static analysis, which means you can statically analyze files, make sure that they, in the parsing phase of the compiler, you can know if there's a syntax error, which is pretty cool. And you get tree shaking in the language. You don't need, you know, Webpack or any cool plugins anymore to do tree shaking. That is really cool. And it also has a dynamic variant to account for any of these dynamically. So everything was perfect, right? Everybody found their perfect fit. Not quite. The problem with ES modules was ecosystem disruption. The entire JavaScript ecosystem was already using CommonJS. Everybody used Webpack, everybody used Require, and everything was working in a way, right? But with this, they kind of broke everything. And this was the push that was needed to put the JavaScript community over the edge, and a lot of bad things happened. But there's been a lot of developments. It's been better now. But to understand how these things work the way they work, let's see how it works behind the scenes. So this is one of the more boring parts. Please feel free to skim a little. And the fun fact is, the module systems in Node.js are mostly written in JavaScript. So this is for the people who are looking forward to contribute or to make their contributions to Node.js or any of these systems, is that they're written in JavaScript. Even though you're not a C++ developer, you can just contribute to those. So let's start with VM fundamentals. How do VMs work? How does V8 work? Isolate in VM language is a VM instance with its own heap. So V8 is like Chrome gets its own heap, Node.js gets its own heap. In Electron, you have two brothers that are, I don't know, Siamese twins, and they both get a single isolate, which is interesting because what's the job of the isolate, right? It usually does heap allocation and garbage collection. How does it work? Is like, so inside the isolate there's a heap and there's a C++ stack that is dealing with all the V8 stuff. But we live in this fairy mystic place that we call the JS land. And we create objects in the heap, in the V8 heap, but we need a way to, like, as long as there's no way to access these objects in JS land, it's useless, right? So how do we do it? Either we can have a pointer, which does not make a lot of sense, because if you have a pointer, it's a static address to the location. This location can change with garbage collection cycles, which you can think of more as a defragmentation cycle in Windows XP maybe. Things are moving along quite a lot, and what we have is a handle. So this handle is an object in the C++ stack that keeps updating the location as soon as things change. And this is also really important for performance reasons because there's no memory leaks that happens on this end. If any object goes out of reference in JavaScript, the handle knows that it no longer exists, and you can just delete the object that is associated with this handle. All handles are grouped together in a group that is called a scope. it doesn't need to be a scope in JavaScript, but they're called scopes because that's the most fundamental way in which we group handles together, right? A context instead is a sandbox execution context with its own set of built-in objects and functions. So that means anything like the math module or the Intel module or the regexp module is different inside different contexts. So each isolate has multiple contexts, and JavaScript code can run in any of these contexts. It can run in any context, and different contexts have different execution environments, as we talked about. So how Node.js basically works is that you have the node process in which there are multiple threads. Yay, we have threading support now. These threads are nothing but Node.js workers. Inside they have libUI, which is the event loop, and V8, which is the isolate. So yeah, and inside of each of those is a thing which we call the Node.js environment, sorry. And the Node.js environment is just an instance of the node stdlib, which is fs or crypto or any of the modules that you use. And they have different contexts inside of them, which is just a bunch of JS built-ins. And yeah, this is basically how a map of a Node.js running process looks. And your code could run inside any of those red boxes, which are contexts. Now, how do loaders work in this environment is that loaders have basically 3 steps. The loaders have a fetch step at which they fetch the module from someplace. Now for ES modules, that means fetching something on the network. In Node.js, that means resolving the path to a file and then fetching that file. They have a transform hook, which means that they run stuff and make sure that the module is in the exact format that they need it to be. And then they have an evaluation hook, oh god no, which the evaluation hook means that they evaluate the whole module and give you the stuff that you need. Now how this works is that you call resolve, you see if it's cached, so we do caching of modules on the front end of the module system. This means that if you require fs 15 times, that does not mean that the fs modules will be loaded from the disk and parsed by the compiler 15 times. That just means that it'll go on. And if it's cached, it's returned immediately. If it's not cached, it's instantiated and then cached and returned. The CommonJS loader has synchronous loading and inline execution. Now, if you remember one thing from the whole CommonJS discussion, this is it. Please keep in mind that CommonJS loads the module synchronously, which, as we said, does not make a lot of sense on front end, and it executes modules inline, which is also, I mean, it makes absolute sense on the back end because, I mean, as long as you don't have your module, you can wait, you can have multiple calls to the network, sorry, to the disk because it's cheap as compared to network calls. So you have a require function that you call, it calls an internal function, it wraps an internal function which is module prototype require inside of the module in Node.js. Module prototype require calls module load, which is the load hook that we talked about, and it works in the following way. It resolves the file name. So it resolves the file name, which is when you say require express, it requires express in the sense that it goes to the disk and finds out the exact path at which express/index.js is. It finds the cache module. If it's in the cache, it takes the module out of the cache. Otherwise, it creates a new module and adds it to the cache. If it's a native module, it does some absolute gibberish, which it's C++, so let's not worry about that. And it makes a new module object out of the module and then adds it to the cache and then loads it. Now it's calling module.load, and you're looking into that. So module.load just finds the appropriate extension that your file is and then takes appropriate action. So I think I'm not the only one who has required JSON files and you know, all other weird forms of files. You can require .node files, which are even weirder. And this is how it does it. So if it's a JavaScript file, it literally just reads the file synchronously. This is where the synchronous comes from. And then it calls module compile. So does anybody have any idea what module compile does? Module compile, and this is interesting, it takes the text of your module. It reads the actual contents of your module. It has a wrapper, which is an iffy wrapper in a string, and it adds to that. So it concatenates that wrapper, and it runs that wrapper into the VM. Now imagine if any of your modules did something really nasty, or maybe your module was just, it started with something that closed the iffy. We'll just blindly run it in the VM, and we're giving the modules that you run absolute privilege over your system. They can do whatever they want in your system, and there's no way we can stop that. So not a good thing. Around a year ago, I changed that. I made a pull request to change that to vm.compile function. So now it takes the source code of your script. Instead of wrapping that around iffy blindly, it compiles that into a function. And if you can call vm.compile. I exposed that C++ code into a function that you can call vm.compile function, and you can use that yourself. It's a really cool function, and it works better. It has better security guarantees. Even though, like, when I say better security guarantees, I mean better than zero security guarantees. I do not mean that it has like a good security model whatsoever yet. That's something that I'm working on. And the ES modules loader, compared to that, it's supposed to be complicated, but again, it's important. It has asynchronous loading, so everything is loaded asynchronously, and then execution is synchronous. So how it works is it's completely async await. When you call import, it's actually an async function that gets this module job. It runs it synchronously because there's an await next to it, and it returns the namespace. Now, guess what? The module job thing is exactly in line with what the CJS loading is done. It's resolving, it then gets it from the module map, which is a fancy way for the fancy name for the cache, and it's just instantiating a new one, setting it in the cache, and returning it. It's, as I said in the flowchart, it's always the same. You resolve it, and then you add it to the cache and return it. What's inside module job, again, is really complicated and beyond the scope of this presentation. So I think it'd be better to talk about it. If you want to later meet me. But yeah, the crux of the presentation is that CJS is easy. CommonJS is an insanely easy thing. We've been doing that for years. We've perfected that, and we're still doing that. We can keep doing that forever. ECMAScript modules are also easy. ECMAScript modules are very easy in the sense that people are doing that, browsers are doing that all the time. Dino, which is created by Ryan, just does ES modules. ES modules are not a hard thing to do either. ES modules is a really good standard, it's easy to do. But what is hard, really hard, is interoperability. It's really hard to make these two completely different systems play well together. Why is it hard, you may ask me? There's a couple of problems. So the first problem is how to detect if a module is ESM or CJS. This does not apply for browsers because browsers, first things first, this does not apply for browsers because browsers, you have a way of telling the browser what kind of module it is. How many of you have written a script tag in the last like 1 year? Nobody? Never, oh yeah. And have you ever written script type equals text JavaScript? Why do you write that? Yeah, it's not a module, exactly. And you can write, you can specify there that it's a module, and then the browser knows that it's a module and it needs to. Now, how do you tell Node.js if it's a module or a CommonJS module? You have no way of telling it. The second thing is that how to import CommonJS modules from ECMAScript modules. As I told you, ECMAScript modules are imported statically. This means that CommonJS, any modules that it imports also imports statically. But CommonJS modules are not static, they're completely dynamic. You know this because you've done module that exports equals, which means it's always just an object that you're returning. It could be anything. So you cannot do static analysis on this. And more importantly, how to import ESM modules from CJS modules. Now this is interesting because CJS modules can have cyclic imports. You, as a library author, can import Lodash, and Lodash can then import you. But this does not work the other way around. This does not work for ESM because it does not have any support for cyclic imports. And it doesn't need to because it's just importing URLs. The specification was never written keeping in mind Node.js. The specification was never done keeping in mind that you would never not require URLs. This is the major point of contention. This is the biggest conclusion from the talk. ES modules were never designed to be written in Node.js, and that's the challenge. That's why we are facing trouble. Now, this answers to these problems. Now, one answer to how to find out if a module is a CJS or ESM module is .mjs. We're sorry for that. I know you hate it, but it's a necessary evil. If you require a file, how do you know if from the file name, period, how do you know from just the file name if the file is an ES module or a JavaScript module? This is the easiest way. Imagine if we did something really crazy, like, you know, you had to encode your files in different encoding. We didn't do that. We made you change the extension. It's so harmless that you can change the extension, and then Node.js knows if it's an ES module, because nobody else would name their files .mjs unless they intentionally wanted them to be ECMAScript modules. So again, this is the most elegant solution that we came up with. This is, I believe, period, the most elegant solution that exists out there. If you think there's a better solution, come talk to me, come talk to us, and hopefully, maybe someday we could change to that, but this is the best we have. The solution to importing CJS files inside ESM modules is that we have dynamic imports in ES modules. So Dominic DeNicola, who's a really good friend at TC39, and he's also at W3C and he's everywhere. And he made a proposal to add dynamic imports in ESM. Now what this means, there's an import function now in ESM. Now what this means is that ESM, the specification itself, has room to import modules dynamically, to import other ES modules dynamically. So it definitely can handle dynamic modules that are not ESM. So Node.js can fill that gap and do that. Now, only one thing remains. There's one last problem, that is cyclic imports. There's no, for a long time, we believed that there was no way moving forward to fix that problem, but that might not be the case. So if you know Alex Rochma made it says a day ago, but a couple of months back maybe, he made a document that had plans for ESM's transparent support for cyclic imports. When I mean transparent interop, it means that you don't have to do a lot of craft work in your own scripts to make sure that it works. It will just work without you having to do anything extra for that. So he has proposed something which is transparent support for cyclic imports. You can again scan that QR code to go to this document, and hopefully we will at some point reach a point where the ES module specification has complete support for cyclic imports, and at that point we will have transparent interoperability inside CommonJS to account for ES modules. That's pretty much it from me. I want to thank a couple of people before I leave. I want to thank Miles for all his work championing modules in Node.js, and also for all the help with this presentation. Anna for all the help in general and with the presentation, you're the best. Shelly and Dimitri for, if any of you know, he's the organizer of Holy.js. He's the one who suggested that I speak about this topic. And actually a big thank you to all the organizers. Could you please give a big round of applause for the organizers? You've been amazing people. And thank you. Thank you for organizing this. You've been an absolute delight to work with. And last but not least, thank you to you all for being such a patient audience.